Welcome to Homework Lib.
Hi, so over here we're supposing that a 500 milliliter flask is filled with the following quantities of different compounds. In this case, since the volume is going to be equal to zero point 0.5 liters, that means that the concentration is going to be twice the amount of the moles that we're going to get. Thus, the concentration for carbon monoxide is going to be equal to 1.2 molar. The concentration of water would be equal to 3.2 molar, and the concentration of hydrogen gas would be equal to 0.70 molar times 2, thus 1.4. Now, with this reaction, we're told that the value for the equilibrium constant K is going to be equal to 9.7 at the temperature of the flask. We want to calculate the equilibrium molarity of CO, rounding our answer to two decimal places. So the first thing that we need to do is that for the reaction, we're going to calculate the value for Q to know the direction that we're going to follow. So the value for Q would be equal to the concentration of CO2 times the concentration of H2 divided by the concentration of CO times the concentration of H2O. In this case, we're going to have none of CO2 in the flask. So just because of that, we're going to know that the reaction, whoops, we're going to know that the reaction will go on the positive direction since the value for Q is equal to 0. And Q, in this case, would be lower than the equilibrium constant. Thus, we can write down our ice table employing the quantities given by the problem. All of the quantities here are going to be given in concentrations. For carbon monoxide, we're going to have 1.2. For water, we're going to get 3.2. For CO2, we're going to have 0. And of H2, we're going to get 1.4. In this case, the amount of change, we're going to call it minus x, and plus x. And we're going to get at the equilibrium 1.2 minus x, 3.2 minus x, and 1.4 plus x. Thus, the equilibrium constant, which would be equal to the concentration of CO2 at equilibrium times the concentration of H2 at equilibrium, divided by the concentration of CO times the concentration of H2O, would be equal to, first of all, to the value that were provided by the problem, equal to 9.70, and would correspond to x times 1.4 plus x, divided by 3.2 minus x times 1.2 minus x. So now what we're going to do is expand this equation a little bit. We're going to get 9.70 times 3.2 minus x times 1.2 minus x would be equal to 1.4x plus x squared. Expanding the left-hand side of the equation, we're going to find 9.7x squared minus 42.68 on x plus 37.248 as the last term over here. Collecting everything to the left hand side, we're going to have directly 8.7x squared minus 42.68 minus 1.4, which gives us 41.28 on x plus 37.248 equal to 0. So this is going to give us two solutions of x, x1 and x2. Over here you can solve it employing your calculator. Any scientific calculator is going to be able to get you the result, or you can employ x12 equal to minus b plus minus the square root of b squared minus 4 times ac divided by 2a, the general formula for a quadratic expression, where a, b, and c are the corresponding coefficients for the equation. Oh, sorry. Over here, I just realized that I had a typo in this section. It should be 44.08, not 41.28. 44.08. So now the solutions that we're going to get for this equation are going to be x1 approximately equal to 1.07169 and x2 equal to 3.99498. So now, which one is going to have physical meaning? Well, let's just look at equations. If the value for x is larger than 1.2, then we would have a negative value. So the correct answer would be x, which is going to be equal to the concentration of CO2, would correspond to 1.07169. In this case, we're asked to round our answer to two decimal places, so it would correspond to a concentration of CO2 equal to 1.07. And with that, it would be all. Thank you very much and have a good one.